Welcome back for another MikroTik RouterOS version 7 video tutorial. Let's connect to one of our routers to have some recap. So far, we have reached the stage wherein we have configured the IP addresses of our interfaces. So we have the loopback interfaces and of course our connectivity to the other routers. Our discussion for this video demonstration will be centered around router ID. So a router ID serves as a unique identifier for a router within certain routing protocols. So we have the routing protocols here, for example, OSPF and BGP. Later in our future videos, you will realize how crucial the router ID is for the correct operation of protocol mechanisms such as neighbor relationships and route advertisements. In RouterOS version 7, you will notice here that under the router ID, you could see an entry already that the router ID is set dynamically. You'll notice here that at router 2, the router ID, dynamic ID, was taken from one of the interface's IP addresses. In case the router ID is set only as dynamic, so the dynamic ID will take from the highest loopback address. So if there is a loopback interface that is present, it will take the highest address out of that loopback interface. To illustrate this point, I go back or connected to R1 instead of R2, and I purposely remove first the loopback IP address in our R1. And if you'll see, the dynamic ID is not taken from the loopback address anymore because there's no loopback. Instead, it took from the active interface, and for which is the highest address. So 13 bits 12 because they are the same in the first and second octet. So 13 is the higher than the 12.1 or the Ether2 interface. We are still at our R1. So however, if we do a manual configuration of our router ID, so therefore this router ID will be the preferred and the use IP address. For example, if we set a manual router ID, so make sure it's enabled. So to clearly describe, so let's type in router ID as the name. Of course, you can have your name. And instead of selecting dynamic ID from static or loopback or active or even the lowest, so we could put in here our ID. So for example, let's have 172.31.255.1 as our example router ID. So click OK. Before we proceed further, so I've removed the router ID which I've added via GUI. So instead, let's go to new terminal and create a router ID here. So it's under routing. Then of course you can press F1. So the closest here will be ID. Then another F1. So obviously you need to add. And another F1. And you have the ID and the name. So let's type in a name. So name equals router ID. Of course you can have your own name. Then the ID will be the IP address, so 172.31.255.1, and of course we'll have our disabled equals no. Press enter and we can do our print. So router ID print, and you have the router ID. Of course we can verify by going to our router ID, and it's back once again. Now let's put back the original loopback address for our R1. So we go to new, so enabled, yes, then we type in 172.31.100.1 on our loopback interface. So click OK. So let's see if our dynamic change. So we open once again, so router ID, and yes, it did change from the 10 to 172.31.100.1. Now what if we decide to say disable once again? So let's say disable. So we have the X flag on our loopback interface. So we close the address list and close the router ID, and let's try to open again. So when we add the loopback address, so it did dynamically change from 10 to 172. But if we have disabled the loopback interface address, so we have disabled, and let's do a close and open again. So it didn't dynamically change. So even if we wait, so let's try to reboot instead. So let's do a reboot, system reboot. Again, this is for testing and taking a look at the behavior. So this should not be done on your production systems that you just anyhow can reboot your router. So yes, do you want to reboot? Click OK, and let's just wait to connect. And it's also a good time for you to take a look at the error in our MikroTik Winbox version 4. And let's just wait for it to reconnect and see if our dynamic ID is updated. Okay, it's back once again. So let's take a look at routing. Router ID, it didn't change. So although IP address is disabled, but the dynamic ID still remains. To add more on this behavior testing, so what if we completely remove the address? So it already have the dynamic ID set to the IP address of the loopback, but what if I remove this loopback address? So remove, so it's removed. So let's close and see how is it. Will it change? No. So let's try to close again, perhaps wait for a while. So router ID, so it's still the same dynamic ID. So even if I reopen again, it's still the same dynamic ID. Let's do a reboot one more time. So system reboot and click OK. So again, you still have this message, connection lost, and let's wait for it to reconnect. And this time the dynamic ID is now updated without the loopback IP address, but because of course we don't have anymore the loopback IP address. In our future videos, so once you have the router ID, I put back the loopback address. So routing, so if we go to OSPF, so under instances, for example new, you'll have the router ID drop down wherein you can have the main, which is the dynamic one, and if you have another manually configured router ID, so it will appear here. So this is where you could set your router ID. I've added a very basic OSPF configuration between our R1 and our R2. So not to discuss OSPF, but to take a look at the packet capture on how the router ID is being used. We are at our R2, so quickly OSPF neighbor. So we have some neighbor adjacencies form on our R1, which carries the router ID 172.31.100.1. So again, that was the router ID of our R1. So similarly on our R1, we also have the neighbor adjacency form, and the router ID was the loopback interface IP. So in our Wireshark packet capture, so under open shortest path first, you'll notice on the OSPF header, you'll have the source OSPF router, which is the loopback IP address. Similarly, for link state updates or route advertisements, for example, so you'll see at the packet capture that the advertising router is the loopback address. And finally, if we click to once more to ls or link state acknowledge, so you'll notice the source OSPF router and the advertising router carries the router ID or the loopback interface IP address.